Okay, we are going to continue section 5.2, finding probabilities, because that's exactly what we were doing, working with tables. So find probability, normal distribution, distributed values, and we are going to learn how to find work with normal distribution, and based on probability find the z-score. So let me go back here. Let's assume we have our x is located somewhere here. This x is located somewhere here. This is x is equal 600. So that means all this blue area, it's a probability. It's the area is nothing else but probability. Remember that. So when I'm saying how much is the area, that means I'm asking what's the probability this will happen in statistics. Okay, mu, which is our average. It's not working again. Very nice. Okay, we'll go. Keep going. Maybe it will start working at some point. So mu is right here, middle line. Its average of population is 500. And sigma standard deviation is 100. If 500 here is 600, standard deviation is 100 for this element. So we need to find how much will be the z-score given the probability. So first thing we need to do, find out what z-score is matching to our x is equal 600. X can be any number, anything. So let me see, z-score is the one who is limited for negative 3.49 up to positive 3.49. Remember, we are standardizing. So the formula for z-score is equal x minus mu over sigma. X is our value, mu is average, and sigma is standard deviation. So in this case, we are plugging all our values. Okay, 600 minus 500 over 100. Let me see if it's gonna work. Well, yeah, 600 minus 500 divided by 100, and that's equal 1. Excuse me. So x is equal 600. It's gonna match z-score that is equal 1. Here it is. If we need to find probability for x is less than 600, it's gonna be matching z-score is less than 1. So before I go and solve examples for this, first of all, and I should have explained this before even I would start, for which I apologize, let me explain to you why do we learn this, what for do we learn this. Okay, for example, let's assume I am baking bread let's go based on this example. I am baking every week in average 500 bread and deliver to Publix to sell. Okay, and every week I pay attention. By Thursday all breads are gone. Okay, very good. Well, now I start thinking, as a true business person, right away you are thinking, well, if it's bread is gone by the Thursday night, then maybe I can bake some more, because weekend is the week, total week is 7 days. Okay, and we assume let's say I wanna bake who knows 700 breads. Because if in average 500, let's say, so and standard deviation is 100, then I'm selling between 400 and 600 breads in average, right? 400 to 600, because 500 plus minus 100, that's a standard deviation 100 here. So in average I'm selling between 400 600 bread. Now I'm thinking maybe I can push to 700. So what am I doing? I am I'm converting this x that is equal 700, converting to z-score, right, through this formula, z-score x minus mu over sigma, and let's say I got whatever z-score is. And based on this z-score, I'm going to the table and find what's the probability. What is my chance of success? If my chance for success is over 80%, obviously I happily run to the store and buy more ingredients to bake more, right? But if my probability will come out less than 50%, then I'm smart enough not to waste any money for buying ingredients where the chance is less than 40%. Okay? So that's where we use this. We can find how much will be the probability. Here we find z-score, and then we go find probability, and that gives us the answer. What's the probability chance for success? Okay, let's assume I calculated 700 breads, which x will be equal 700, and it came the 50%, about 52-55%. Well, I am hesitating. I don't know, 50, it's not good for business, 50-50. Then I'm thinking this way, okay, if this is 700 is 50%, then let me find out how many bread then will make it 800%. Obviously, it's going to be less bread, right? But I want to know, if it's not 700, then how many? It could be 670, 680, right? So what I'm doing, I'm going to, remember we just learned in previous recording, let's say I'm going to the table of z-score, okay? Finding this 80% probability, which will be 0.8 approximately, right? Figuring out how much will be the z-score. We already know how to find out. Well, let's say 1.8 here is 7. So z-score is 1.87. And then from z-score, I can convert to my x. From z-score, I can convert to my x through formula. I will tell you how. And whatever x will give me, let's assume, now don't hold me responsible. Let's assume I got about 670 breads. Well, that's much better. So I won't bake 700. I will bake 670 bread. So 70 bread more. And with 80% probability of success, and that is much, much better, correct? That's where you can use this probability. All right, so let's see where we are. Moving to this one, let's see if it will work. No, it's not gonna work. Well, that's okay. We'll survive with red color. So, a survey indicates that people use their cell phones an average of 1.5 years before buying new one. So it's our X, right? 1.5. The standard deviation is 0.25 years. So standard deviation is 0.25 years. Look, it's a bright example how to use it in business. A cell phone user is selected at random. Find the probability that user will use their current phone for less than 1. We need to know how much will be for less than 1. before buying new one. Well, I think with nowadays prices on the phone, that would be unbelievable. So people would buy in less than 1 year. So because the prices are crazy. But well, let's see what will be the chance. Okay, and we assume that variable is normally distributed. It's crucially important. If it's not normally distributed, we cannot apply z-score method. So I would recommend you to write down this data so you can follow me, because I'm moving to next slide. Okay. So here it is. Our mu average is 1.5. Oh, wait a minute. Let me go back. Oh, on average. Okay. It's a mu. My apologies. See, it says average. On average, I didn't pay attention. 1.5 years. That's why we have here 1.5. Sigma is 0.25. So we need to find the area probability that will be less than 1, which is for less than 1 year. So in this case, what we're going to do, we need to convert x, that is 1, convert to z-score, right? Find out how much will be z-score, because to get to the table of probability, probability can have access, only z-score can have access. Therefore, our x value, we need to convert to z-score, and then via z-score have access to probability. Okay? By the way, so far I'm using table based on given z-score finding values, which is, let's say, given z-score. Here it is, if it's z-score, finding the probability, value of probability. Okay? So, z-score is equal x minus mu over sigma, which is 1 minus 1/2 over 0.25, negative 2. Well, the fact that z-score is already negative 2, that tells me it's definitely gonna be less than 50%, remember? Because negative z-score, meaning less than 50%, and because the minimum of z-score, negative 3.49, and we have negative 2. So if this is negative 3.49, negative 2 is not that far from negative 3.49, so it's going to be very low percentage, as we would expect, right? I don't know anybody who would buy the new phone with $1,000 worth at the price would buy in less than 1 year. And as a proof to that, statistics showing. So we got z-score negative 2. So now go to your table, find the z-score negative 2 and see how much it will be, which means you are going to take z-score is equal negative 2.00, right? Which means you are going to look, find negative 2.0 here and 0 right here. And that will be value probability for negative 2.00. So the value should get 0.0228 here, 0.0228, which is gonna be, if I move, here is my position 1 and 2, I will get 2.28%. This is what's the chance of people buying the new phone in less than 1 year, which statistics practically is proving the point of our logic. Next one. Finding the probabilities for normal distribution. Let's see what we have here. I would highly recommend to put this recording on a pause and start solving on your own. And only when you see you cannot solve it, you can come back and check it. Or even after you solved it, you can open and check it. So, A survey indicate and those are examples. You can see how you can use statistics in the business in this case. A survey indicate that each trip to the supermarket, a shopper spends an average of 45 minutes in average. (45 minutes) with standard deviation of 12 minutes. The length of time spent in the store is normally distributed and is represented by variable x. Shopper enters the store. Find the probability that the shopper will be in the store between 24 and 54 minutes. So we have x1, 24, x2, 54. Remember what is remind you when we need to find. So if average is 45 minutes, then 24 falling on this side, right? 54 falling closer to 45 in this side. So to find this area, what we need to do, this is a shame I can't change the color. Hold on, let me go back. Well, never mind. So to find the area, I need to find the probability of x equal 24 or less than 24, rather saying, which will be this area, right? And then find the probability for x is less equal 54, which would be all this area, all the way to the end. And when we subtract this piece, this piece, we take and subtract from this piece, you will get this piece. Let's go look how we are solving. So here it is between 24 and 54, right? So we need to find z-score for both. 24 minus 45 over 12, 54 minus 45 over 12. It's matching 2. 24 matching z-score negative 175. For 54 matching z-score for 0.075. Okay? So, z-score greater than negative 1.75 and less than 0.75. We need to find it. So one more time, so I need to find the area that is less than a negative 175, and then find the area that is less than 0.075. And if I subtract the whole this piece area from this area, this area, subtract from this area, I will get this blue color area. And that will be the probability, the chance of success for the customer, shopper stays in the supermarket between 24 and 54 minutes. What do you think using logic? Is it possible? I think it's quite possible if it's supermarket. Yes, we are staying there between 30 and 50 minutes indeed. Okay. And here it is. So if you look in the table, probability for z-score equal negative 175 is 0.7734. Wait a minute. This is probability for 0.75. Yeah, we can't have negative more than 50%. So this is for 0.75 z-score. And this one is for z-score equal negative 1.75. Okay. So you subtract from each other and you get 73%. And remember what I said based on logic also? Yes, it is absolutely normal. Okay. So 73%, which means it's a high chance, so the people will stay in supermarket between 24 and 45 minutes. All right. Next example, it's the same thing. It's just the previously we saw for one shopper chance to stay between 24 54. Here we are looking for 200 shoppers stay between 24 and 54. Okay, which is going to be, the result is 73% that we found, that is equal 73.33%, right? So we multiply by 200 because it's 73.33, that's for one shopper. Okay? So we multiply by 200 and get 146 and 66 shoppers. But will stay. If it's asking 200, so practically that means, this is how we are interpreting. If 200 shoppers enter the store, there is a 73% chance that 146.6, which means 146, I'm rounding not algebraically but meaning wise, because if I round to 147, where from I'm going to take half of the person, right? So I take one less. So that means at least, so maximum 146 people with 73% chance will stay for between 24 and 54 minutes. Okay. Next one. Find the probability that the shopper will be in the store more than 39 minutes. More than 39 minutes. So if we need to know more than 39 minutes, that means x is going to be greater equal 39, right? Not even greater, it says more than, equal sign is not there. Okay, so mu, it's using the same data, 45 minutes, and sigma is 12. And everywhere we have minutes, obviously. So x is greater than 39. Let's see how we're going to solve it. When we are interested in greater than 39, that means we are interested in the right tail, right? Not the left tail. For left this tail, it would be x is less than 39, but for this one. But for this one, it looks like x is greater than 39, correct? So we are dealing with right tail here. Okay, let's go ahead and solve it. X is greater than 39. First, we have to do convert to z-score. Remember, x you have to convert to z-score, and then use the table to get probability. So how much will be our x if you convert to z-score? 39 minus 45 over 12. So negative 0.5. So negative 0.5, and it's going to go to the right again because x is also to the right. It says greater than. So z-score has to be greater than a negative 0.5. How are we going to deal with this? Remember what we learned. If z-score is greater than negative 0.5, we need to find probability for z-score equal negative 0.5, which will give you less than, I can even for precise less than, will give you this area. So whatever probability we get, then we take 100%, because all this area is 100%, or 1, subtract whatever we get here. Let's see. So what's the area probability less than negative 0.5? It's 0.3085. check in your table and find the probability. Okay? Once you found it, moving to next slide. What do we have? Not next slide, next step. So that's mean 1 minus 0.3085, precisely what I was telling you. And here is we get 0.6915, which is means 69.15%. That's mean there is a 69% chance that more than the people will stay in the store more than 39 minutes. So practically it's kind of pushing. It's a less chance, but still, well, quite a few people looks like are going to stay. It's 69%. All right. Well, and now same thing is asking for 200, which means again we are taking this 0.6915 multiplied by 200, which means out of 200 shoppers, it's a chance that 138 people, it's a with 79% chance we can say that 138 people will stay in the store for more than 39 minutes. Well, we are not using any technology besides of Excel. In Excel, it's going to be normal distribution. Well, since I showed you binomial, you can put this function and filled out the steps that you have here, looking at this table. I mean, you're looking at this program here. Let's see what it says. The mean triglycerin level in the United States is 134 milligram. Assume that triglycerin of population of United States are normally distributed, and standard deviation is 35 milligram per deciliter. You randomly select person from United States. What is the probability that person triglycerin the level is less than 80? So X is less than 80. So 134 is your average because it's mean triglycerin level. So you have everything you need. Looking at this data, 80, 134, 35. What was our 35? Yeah, that's standard deviation. So it looks like first number you are going to enter 80, which is going to be your X, less than 80. Second number is going to be your average. Third number is going to be your standard deviation. And the last one you put true, because whatever question will be, you can read it. That means it's a true case. And with this function, norm distribution, you will get the answer 0.0614. Unless you have the scientific calculator that taking care of statistical formulas also, you can use this function, normal CDF, and plug this data and you will get the result. But I would prefer Excel because it's more popular in business. Okay, I finished 5.2, so I will record 5.3.